Welcome to my favorite meme. Today we're gonna integrate 1 over 1 plus a times tangent square x. And this is a bit of weird integral, you know. If this a is equal to 1, it's just 1 plus tangent square x, and this is just equal to secant square x. And then 1 over secant square x is just cosine square x. You can do the integral of cosine square x by using the reduction formula. I think it's called reduction formula. Yes. Cosine square x is equal to 1/2 times 1 plus cosine 2x, right? But this is not 1, and this is a. This is just a variable, but we can let a equal to 0, right? This is a variable, so what are we gonna do? It seems that it's impossible to integrate, but 1 over 1 plus a times tangent square x. I would like to use some substitution here. If the top we get a secant square x, we can let, and when the variable let t is equal to tangent x, right? And then dt is just equal to secant square x dx, right? We want the top to be our secant square x dx, right? So I would like to multiply by secant square x on both the denominator and numerator, and then you get secant square x over 1 plus a times tangent square x times secant square x dx, like that. So we can let our t is equal to tangent x, right? And then our dt is equal to secant square x dx. And the top, we just get our dt on the top. So over you get 1 over 1 times dt, right? dt over that is equal to 1 times dt. Yes. 1 over this and 1 times dt. They are totally the same. And then 1 plus a, and then tangent x is equal to t square that. And then what is our secant square x? We know secant square x is equal to 1 plus tangent square x. So this is equal to 1 plus 10t square in our t world, right? So here, how can we integrate it? Here, we have two multiplication, right? They multiply each other. These two parentheses thing, I think. So I would like to use partial fraction split to two different fractions. One, I don't know what is on the top, and then plus what over this 1 plus t squared dt. And here, to do the partial fraction, first we're gonna write down this 1 over 1 plus a times t squared times 1 plus t squared is equal to that. We're gonna split to two different fractions, right? On the this, you need to check the variable of this. T squared, you need to take a less power, just one less power, so this at, and then don't forget to add b here. And then here, 1 plus t squared, and then t squared, the power is the second power. It's square, right? T squared. So take out one less power, you get ct plus d. So overall, multiply by 1 plus at squared times 1 plus t squared on both sides, you get 1 is equal to at plus b times 1 plus t squared plus ct plus d times 1 plus at squared, like that. So overall, just break the parentheses, you get at plus at cubed plus b plus bt squared plus ct plus cat cubed plus d plus dat squared. Like that. And here's the deal. I would like to combine it. T cubed, let me factor it as, look at the t cubed and t cubed. Let me just factor it as a plus ca times t cubed plus what's our square? Just factor it as b, and then plus dA times t squared plus what's our t is a plus c times t, and then our constant is just our b plus d, right? And then compare both sides. By comparison, you get a plus ca is equal to 0, right? Because the coefficients of tq here is 0, right? And then b plus da is equal to 0 as well, and then so as a plus c is equal to 0. And then the only one is just a constant. Compared to both sides, the constant here is 1. So b plus d is equal to 1. Like that. Wait a minute, do I make some mistakes here? A plus ca is equal to 0. Let me check it out. A plus ca is equal to 0 is correct, and then you always kind check your answers, because if you don't check your answers, probably you will do some steps wrong. And then b plus our dA, and then a plus c, and then b plus c, and it's okay. And here, look at this. A plus ca is equal to 0. A plus c is also gonna be 0. So let me just subtract subtract this. A and A, they are cancelled, and then factor out the c, you get a minus 1 times c is equal to 0. And then a minus 1 divided by a minus 1 on both sides, you get c is equal to 0. And then so as put it to here, you get a is gonna be 0 as well. And here's the deal. We know a is equal to 0, c is equal to 0. We're gonna figure out what's b and d. Look at these two equations. This subtract this. B and B, they are cancelled, and then factor out the d. You get a minus 1. But be careful, this time it's negative 1. Right? 0 minus 1 is negative 1. It should be multiplied by d here. So you get d is equal to negative 1 over a minus 1. Let me just leave this to you guys. Negative 1 over a minus 1. And then put it back to here, you get b minus 1 over a minus 1 is equal to 1. And then b is equal to our 1 plus a minus 1. 1 plus 1 over a minus 1. And then we're gonna get the same amount later. You get a minus 1 here, and then plus 1. So you get a over a minus 1 like that. So over our constant, the thing we get here, we know a is equal to 0, so we only care about b. So this a minus a over a minus 1. And then our c is also 0, and then only care about d is negative 1 over a minus 1 like that. So over, I would like to factor out the 1 over a minus 1 here. 1 over, wait a minute. 1 over a, this kind of annoying. 1 over a minus 1 multiplied by, let me just put an a here. We're gonna do the integral of 1 over 1 plus, I would like to write it as square root of a times t, and then square that dt, and then put the a outside, right? And here I would like to write it as negative multiplied by 1 over 1 plus t squared dt. So here's the deal. This is really easy. You can use the inverse tangent, right? So over, this is just a over, let me just multiply by 1 over a minus 1 into this two different integral, right? Multiply, you know, this is the most disliked thing. This is very annoying. Let me try to write it. So over here is the deal. First, you will get inverse tangent here, right? 1 over 1 plus something square, you get inverse tangent of something. Inverse tangent of square root of a times t. But don't forget to multiply by 1 over square root of a as well because of the chain rule. On integral, you're gonna do it backward, right? Unlike integral, unlike the derivative. Square root of a. And this here, minus 1 over a minus 1, and then multiply by inverse tangent a, right? Inverse tangent t. Because it's in our T. I think that's our answers. But no, we can simplify. This is a power of 1 over square root of a. So this is just square root of a, right? Square root of a over a minus 1. You multiply by inverse tangent of square root of a times t minus 1 over a minus 1 times inverse tangent of t. But this not our final answers. We're gonna change it to our x one here. T is equal to tangent x, we know that. So this is equal to square root of a over a minus 1 times inverse tangent of square root of a times tangent x. And the minus 1 over a minus 1 times inverse tangent of t. We can take the inverse on one side, you get x is equal to inverse tangent of t. So this multiplied by x, this is the same as. I think that's our answers. This and this, they can't be simplified anymore. Let me just put down the c. And that's our final answers. This is really cool, right? Square root of a over a minus 1 times inverse tangent of square root of a times tangent x minus 1 over a minus 1 times x. The c, and that's it. But inverse tangent of tangent x is not exactly equal to x. So if you need to focus more on the domain, I think this answers will be better. Square root of a over a minus 1 times inverse tangent of square root of a times tangent x. And then minus 1 over a minus 1 times inverse tangent of tangent x plus c. I think this will be better.